Attention, ladies and gentlemen. Welcome to this masterclass about the powerful, the beautiful one sample t-test, t-distribution in general, and one sample t-test. Please, on a scale from 0 to 10, how is my audio? Who knows the name of this song? In this rainy Tuesday, August 29th, I say that it's a pleasure to have you all here. I can see Lucombo, I can see Honey, I can see Nikisha, I can see Trex, Emmanuel, Angel, I can see Hussein, my dear friend Hussein, one of the first green belts certified outside Brazil by myself. Wagner, I can see the famous Herman from Colombia. I can see Ricardo Gonçalves do Brasil. Tudo bom, Ricardo? I can see Honey. I can see Patrick. I can see the top one participant in all events of MF OPEX, Vindra, that, if I am not wrong, is in Trinidad and Tobago. You know, I can see Carl, that is always here with us as well, Rodrigo, Joanne, and everybody else. I'm sorry if I did not say your name, but please know that you are very special and I am happy to have you here. If possible, type from where are you taking this session today. From where are you taking this session today? From which country? So we have Nigeria, we have Philippines, 8 p.m. in Philippines, I believe. Philippines again. We have Ghana, we have UAE, we have Kenya, Burkina Faso, we have Bosnia, we have Philippines, we have Botswana, Angola. That's amazing. South Africa, Sudan. Wonderful. Excellent. Okay. Why are we here? Why are we here? Why are we in this open masterclass on YouTube? Why are we here? We have one single mission. I want to contribute. I want to support you. I want to help you to become a respected, a well-recognized problem solver. That's the point. I want you to promote positive and big impact in the corporate where you work for, in the company where you work for. I want you to be more assertive. I want you to, at the end of the day, be extremely employable, internally and externally. Yes, there are many ways to be employable, but definitely if you like continuous improvement, one of the most robust ways to be employable, it is to learn how to solve problems. Yeah? So I do offer free white belt certification programs. By the way, right now we have more than 80,000 people certified live sessions like we are having here. This is the entry level. The entry level is free. The other levels are not free. The next level is yellow plus green. Yeah, I like to say that the next level is green with a bonus of yellow. And then if you decide to take the next step, then we have the black belt certification program, and the final stage is master black belt. Yeah, so we have, let's say, 5 different belts: white, yellow, green, black, and master black. Yes? Wonderful. In this open Q&A, I know that I am talking with white belts, I'm talking about yellow belts, I'm talking with green belts, I'm talking with black belts, with master black belts. Yes? So, and sometimes I'll be touching concepts that are green belt concepts, sometimes black belt concepts, sometimes even master black belt concepts, But I do my 200% here to explain this in a way that you can understand, even if you have never heard about white belt, okay? Again, because one of my most important objectives is to guarantee that your assertiveness is on the other level, that your employability went to the next level. Yes? Wonderful. And today's topic is by far one of the most important topics in the Lean Six Sigma body of knowledge. Yes? T distribution. So we need to talk about the famous William Gossett. Yeah, William Gossett. And you can, nowadays it is so easy to search, online about anyone. If you want to take a look, in the history of this gentleman, let me show here a picture of this gentleman. Yeah, William Gossett. This is the gentleman, William Gossett. And we will find like different histories and maybe stories about William Gossett. There is one story that says that he proposed the T distribution, but he was kind of insecure about what he was proposing, and that's why he signed off as student. He did not put his name. Yeah. We will hear that he was using some data that was not shareable, and that's why he did not write down his name, in the paper. But the fact is, he is the one that proposed the famous T distribution. T distribution, yeah. And based on T distribution, we have the famous family of t-tests, yes, because we have the classic t-tests like one sample t, two sample t, but in fact t-test we will see in many other techniques. For example, DOE, design of experiments, we will have a portion of DOE that uses a t-test, okay, uses t distribution, yeah. So my objective with you today, normally I spend from 30 minutes to 60 minutes, is to explain in a very friendly and simple way what is t distribution, yeah, what is t distribution, and I would like to explore one sample t, okay, one of the most famous t-tests using the t distribution, okay, from 0 to 10. How excited are you to deep dive in this topic? And okay, Marcelo, how can t distribution help me to be more assertive, to be a better problem solver? Oh, 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 t distribution can help you to justify scientifically if the impact that you promoted in a process is statistically significant or not. You do this using t-tests. T-test is very helpful to check if, based on a sample, if the projected parameter of the population is greater than a certain value, less than or equal, greater than or less than, or simply different from a certain hypothesized mean. And this hypothesized mean can be a target, for example. So you can, on measure phase, assess, process performance. Yeah, even knowing that capability analysis will be our best friend for that. But you can use two sample t to validate root causes. Choose sample t to validate root causes. Yes. Wonderful. Beautiful. So let's go ahead. This is Minitab. I think you guys know about this software. If you use another software, that's okay. No problem at all. And I want you to tell me how familiar are you with this concept here. How much do you understand when I plot the famous, who knows the name of this distribution? Who knows the name of this distribution? Who knows the name? Yeah, this is the normal probability distribution. Yes. Excellent. And I have a mean equal to 10 and a standard deviation equal to 1. Okay? What is a probability distribution? What is a probability distribution. I support Flamengo. Flamengo is my team here in Brazil, my soccer team, my football team. I support Flamengo. If Flamengo is playing against a team named Vasco, that it's not a very strong team right now, I can argue that there is a chance, there is a probability that Flamengo will win. This chance varies from 0 to 1. From 0 to 100%. Yeah? Wonderful, excellent. So I can argue that there is a 99% chance of Flamengo winning Vasco. Yes, right now. I can argue that there is a good chance. And if we consider only winning or not winning, we can talk about binomial probability distribution. Yes? Okay. So probability varies from 0 to 100%, from 0 to 1. What is a probability distribution? What is a probability distribution? Let me use here an example that I have never used before. Let me talk about Brazilian cheese bread, okay? And I am talking about the Brazilian cheese bread weight, yeah? One of the most famous foods in Brazil. So I can argue that the mean of the cheese bread weight is 10 grams. So what is a probability distribution? I am distributing here different values of probability. For example, what is the exact probability of take randomly. I see there a lot of cheese breads. Picture that with me. I see there a lot of cheese breads, 1,000, 10,000 cheese breads. If I take one cheese bread, boom, randomly, what is the chance? What is the probability that this cheese bread weighs 10 grams? What is the probability? Who knows? What is the probability of weighing exactly 10 grams? Exactly 10 grams. So see, I can take here 10 grams. Take a look. I can take 10 grams. I can come here. No, see, that's the point. If we have 1,000 cheese breads and I take one, if I say that the probability is 1 divided by 1,000, then I am saying that all cheese breads, they have the same chances. They have different weights. And what the probability distribution shows us is that no, there is a higher probability of being around 10. There is a higher probability. Marcelo, can the cheese bread weight 8? Yes, but see, this probability here, take a look, is different from 10. Take a look. It is different. It is different. And I really need to guarantee that you guys understood that. And because that's the thing with the probability distribution. I can take a look and then I see, whoa, close to 10, the probability is higher. So it means that if I take one cheese bread, just one cheese bread, the chances of getting this cheese bread close to 10 is higher or lower than taking one cheese bread with 7, for example. Type here for me, higher or lower. If I take just one cheese bread, the chances of weighting around 10 is higher or it is lower than weighting 7, for example. 10 and 7, it is higher or lower? Yes, it is higher. It is higher. It is higher. I mean, statisticians or mathematicians can argue that we cannot talk about one specific, one exclusive value for weight. Yeah, because this is a continuous distribution. So we should always, we should prefer working with intervals. For example, I can come here and say, please, what is the probability? What is the probability of a cheese bread weight from 7 to 10? What is the probability of a cheese bread weighting from 8 to 10, let's say, from 8 to 10? Yeah. Interesting. So if I randomly take one cheese bread from a population that behaves like this, there is a 47.72%, 0.4772, 47.72% probability chance that it weights from 8 to 10. Okay? From 8 to 10. How much are we on the same page? Are we on the same page? Type yes if we are on the same page. Type yes if we are on the same page. Yeah? Yes, Vindra. Yeah, if you are taking out of 10 or out of 100 or out of 1000, for us here in this scenario, in this specific example, it doesn't matter. It doesn't matter. For binomial, it matters. It matters, yes. Because then it's proportion. Yeah? Okay, so see, this is the normal probability distribution, and I'm talking about taking how many cheese breads that I've mentioned here. How many? How many cheese breads that I took in this example? Type here for me. How many cheese breads that I took here in this example? Just one. Yeah. Now, Now, in order to introduce the concept of t-distribution, I need your full attention. Come here with me. I need your full attention. Full attention. Full attention. Imagine that I have my population of cheese breads, a lot of cheese breads there. And now, I don't take one cheese bread. Now I take randomly 10 cheese breads. 10 cheese breads. And then, instead of plotting 10 data points, I'm gonna calculate the mean, the average of these 10 cheese breads. And then I'll have one number. I'll have one number. And then I go and I write down, this number. Population of cheese breads. I went there, I took 10 cheese breads and I calculated a mean. Okay, 10.1. And then I went there again and took another sample of 10 cheese breads. Boom. And calculated the mean again. And then I found 9.9. Are you guys following me? Are you guys following me? Type yes. And then I took another sample, and then I found 10. And if I keep doing this exercise of collecting samples and calculating means, I will have a lot of means. I'll have many different means. A good question would be, how do these means behave in terms of probability distribution? It's a fair question, right? It's a fair question. What about the distribution of means? What about the distribution of means? Are you guys following me? Yeah, it's a fair question, right? And that's where t-distribution comes to play a very important role. Very important role. T-distribution is a distribution of means. From 0 to 10, how much did you understand that? T-distribution is not for individual values. Yet there was a question there. How do we reach this 0.772? It's an integral. I don't know if you are into math. Normally, engineers, mathematicians, statisticians, they know this very well. It's an integral. Yeah? And then with this integral, you can find the area under the curve. Yeah? Under the distribution in this case. And then you can set limits. For example, integral of this normal probability distribution with mean 10, standard deviation 1, from 8 to 10. Then you have an area. And this area is always from 0 to 100. Yeah, percent. From 0 to 1. And by the way, there is no absolute 0 and there is no absolute 1. Because it starts on minus infinite and it ends on plus infinite. There's an asymptotic behavior. Asymptote. Yeah, they will never truly touch, the x-axis. Yeah, never. They will touch on infinite. Yeah. Yes, wonderful. Okay, Marcelo, and how is the shape of a t-distribution? The shape of a t-distribution is relatively similar to the normal probability distribution. Yes, but you can use in a very simple expression, you can see that the distribution will tend to be kind of thinner. Let's plot here. Let's plot here a t-distribution. Very similar to a normal probability distribution, just this dimension here that tends to be a little bit shorter. Yeah. Then when you increase the number of degrees of freedom, it gets even more similar to the normal probability distribution. Yeah. And if you reduce the degrees of freedom, yeah, it tends to be thinner, if this is a good expression. Yeah. And Marcelo, what is degrees of freedom? In our case here, just to keep it super simple, you can consider, I've mentioned Vindra, right? Vindra from Trinidad and Tobago. So Vindra has a house in Trinidad and Tobago. Let's suppose he has a house in Dubai. And then Vindra has a house in Singapore. Vindra has a house in Paris. If Vindra is kind of bored in Trinidad and Tobago and he wants to go to another house, how many options does Vindra have? Well, he has Dubai, Singapore, and Paris. He has four houses, but he is bored in Trinidad and Tobago. He has n-1 options. If he's in Paris and he's bored, he has Trinidad and Tobago, Dubai, and Singapore. Yeah, and yeah. Correct? n-1. Wonderful. No, Drex, we will still prefer to work. Normally t-tests we use when the sample size is not large. Yeah. So in the Lean Six Sigma context, we will keep this recommendation. Yeah, this recommendation. By the way, in the example that I'll be showing here, we will work with 10, a sample size of 10. Yes. Okay, so degrees of freedom will be pretty much your sample size, in this case, -1. Your sample size -1. Yeah? Wonderful. So, okay, interesting. So now that we understood, type here for me yes if you understood that the t-distribution is a distribution of means. So when I say, for example, 0, I'm talking about a mean, an average. When I say -2.5, it's a mean. 2.5, it's a mean. I'm not talking about individual values. No. Don't do that. Don't do that. You guys know that it hurts Marcelino's heart It hurts Marcelino's heart. Don't do that. Every time that you guys ask in the middle of an explanation if there is a certificate today, Marcelino internally cries. Every time that in the middle of the explanation someone asks, is there a certificate today? I just wanna cry. Because in the middle of the explanation, when you ask if there is a certificate today, it suggests that you care more about a document, a PDF, your LinkedIn, your resume, than the knowledge. Document. Certificates are external elements. We must care more about our internal system. You know, we must learn. Marcelo, but you talk about white belt certification, yellow belt certification, green belt. I know. I talk about that. Because in Lean Six Sigma we do have certification programs. But this is a masterclass. This is a technical session where we are going deep. We are going deep here. Deep. And if you learn what is a T distribution, you will be ahead of so many people. You will be so much well prepared for job interviews, to apply in your regular job, in your current job. So well prepared that the document doesn't matter. Believe me. When you are in the middle of an outbreak in your company or running a Lean Six Sigma project, it is very unlike that someone stops the project and asks, okay, show me your certificate. How many certificates do you... I'm sorry, how many certificates do you have? I'm sorry, can you show me your... It's very unlike. But if in the middle of a meeting or during the development of a project, you kindly raise your hand and say, hey, we should plot means instead of individual values. We should validate the root cause using t-distribution, using t-tests. We should validate the improvement using t-tests. Come on, guys. Pareto. Prioritization. You know? What is more important? You guys tell me. Knowledge or document? What is more important? What is more important? With love, with love. Please feel the love. Please feel the love. Please feel the love. Please feel the love. Is type here me if you had lived a situation like that, if you had practically used anything that you learned from me in your work and it has impacted your career. Type here me. If you had, since the first time you met me, if you've practically used in your job and it has positively impacted you, the project, the company, yes? Yes, so I mean that at the end of the day, that's my mission. That's why I am here talking to you guys, because of the transformation that happened to Catherine, to Yosra, one of the best black belts I have ever certified, with tracks, with word trade, with honey, you know? That's the kind of transformation. Yeah? With love, with love, with love. Guys, so let me take here again cheese, bread, weight. Cheese, bread, weight. And let me generate here 10 data points, okay? And then let's suppose this is a sample. This is a sample of a population of cheese breads, many cheese breads, and we took a sample by the size of 10. So one of the things that you can do is you can come here, stat, basic statistics, and one sample t. Stat, basic statistics, and one sample t. And then you can compare this, for example, against 11. But I want to explore what is this? What is this? What am I trying to do here with this one sample t? Evaluating a sample by the size of 10, performing this hypothesis test, okay? So let's see what am I doing here? What am I doing here? Yeah, or to be even more interesting, I'm gonna do with 10.5, okay? With 10.5. I think it will be even more interesting. So, what am I doing here? And please tell me here, what is 10? What is 10? This is the sample size. What is 10.152? This is the mean of these 10 samples. population, many cheese breads, and I don't need to know how many cheese breads in the population. I took a sample of 10. Then I calculated a mean. This is a sample mean. Then I have a sample standard deviation. This is a sample standard deviation. And then I have the famous standard error of the mean. That is nothing but standard deviation divided by square root of 10. Yeah? And maybe we can do this just to make it as clear as possible. So, tracks, hypothesized mean, we are talking about the mean that we want to compare with the projected population mean. Because when I take a sample of 10, I am trying to infer, to project the population mean. I took a sample of 10. But what is the population mean? What is the population? I don't know. But we can infer. We can project. And then I want to compare this population mean against what we call hypothesized mean. That can be a target. For example, in this case, let's suppose we don't want cheese breads going above 10.5 in terms of weight. We don't want, because then clients don't want cheese breads that are too heavy, for example. So what is the population mean? I don't know what's the population mean. What is the sample mean? Who knows? What is the sample mean, guys? What is the sample mean? What does the sample mean? What does the sample mean? And Lisa, here we can use as synonymous, even knowing that average, we can associate average to mode, to median. Yes, here we can use as synonymous. So see, 10.152. I have a question for you. 10.152, and I want to check if the mean is less than 10.5. I want to check that if the mean is less than 10.5. Wow, I already know. I know 10.152. 10.152 is less than 10.5. So I can go ahead and write down in my PowerPoint to my customer, to my manager, saying that it is all right. I don't want cheese breads weighing more than 10.5. I took a sample of 10. The sample mean is 10.152. It is less than 10.5. So we are good. Do you agree or do you disagree with that? Do you agree or do you disagree with that? I have cheese breads. I have cheese breads. I have cheese breads where the mean is 10.152. My customer wants below 10.5, so we are good. I see a mix of agree and disagree. Guys, I am not talking about the sample. This is sample mean. And this is what? This is population. This is population mean. I am interested in the population mean. I am talking about the population mean. I took a sample and the sample was 10.152. But what if I take another sample? It will be below 10.5. What if I take another sample? It will be below 10.5. I don't know. And that's why we are using t-test. Because with t-test, we will be able to calculate a limit, an upper bound for the mean. So what I'm saying is there is a 95% chance that the population mean can go up to 10.76 in practical terms. So you guys should disagree with my statement. Should disagree. Because based on a sample, I want to infer the population parameter. Yeah? So, let me open up here just to show something for you. Few important points. Mean, the presented mean, is the sample mean. Yeah? So, 10.152 is the sample mean. We want to understand if the population mean is less than 10.5. That's our, let's say, our research question. Yeah, that's our research question. And then I can calculate standard error of the mean. Standard error of the mean, that is equal to 10.152 divided by square root of 10. Square root of 10. See what I did here. Sorry, it's the standard deviation. I'm so sorry. 1.049 divided by square root of sample size. So it is standard deviation of the sample divided by sample size power 0.5. Yeah? With this standard error, if you guys want to check the formulas, it is not like extremely difficult, or maybe it's not difficult at all. When you click in Minitab help, please let me know if you guys can see the Minitab help. You have almost always on the left side, you have overview, hypothesis, data considerations, example, you know, and you have here methods and formulas. Methods and formulas, you know, and then you have the formulas for the confidence interval. Yes, take a look here. And see that we are talking pretty much about a certain value of t, a certain value of t, yeah, it comes from a table, multiplied by the standard error, okay? Certain value of t multiplied by the standard error. This is the two-sided test. Here we are using the one-sided, but just so you know that the way to calculate the confidence interval boundaries, it is not super complex, okay? You just need to know what's the t-value for the alpha that you are using. And normally we'll be using alpha of 0.05, 5%. And alpha comes from confidence level, that is 95%, 1 minus confidence level, okay? So, what Minitab is telling us is that we have here this boundary of 9.76. Interesting, very interesting, very interesting. Now we have few things to do. What is this t-value? What is this t-value? Yeah, and there are many ways for us to discuss, to explore this part of the result in Minitab. One of my favorite ways to do this is, let's calculate this t-value. T is nothing but sample mean minus hypothesized mean divided by standard error of the mean. Whoa, interesting. So t is equal to 10.152 minus 10.5 divided by standard error. Yeah? T distribution will always be centered in this test, in the way that we are doing here. For one sample t, will always be centered in zero. So let's see what happens when we plot in the t distribution the t-value. Let's see what happens. Yeah? Let's see what happens. So if I come here, graph, probability distribution plot, let me take the t distribution. How many degrees of freedom? How many degrees of freedom, guys? How many degrees of freedom? I have a sample size of 10, so it is 10 minus 1, so 9 degrees of freedom. 10 minus 1, beautiful. And then let's see what happens when I put here minus 1.05. Minus 1.05. Let's see what happens. Yeah, let's copy this guy here. So what is this area? 0.16. 0.16. Anyone can connect this area here with anything? Zero point 0.1607. There is some rounding error here that you may fix if you put the exact or with a greater number of decimal places for the t-value here. For example, if you put 1.04946, yeah. So what? Who can tell me what is this? What is this? 0.1607. What is this? What is this? What is this? This is the p-value. This is the p-value. This is the p-value. It is a little bit dangerous to say that p-value is a probability, but let's say in practical terms we can argue that this is a probability of rejecting null hypothesis when in fact we should not reject. In practical terms, it is the probability of you writing down on your PowerPoint that it is all right. It is all right. And in fact, it is not. And in fact, it is not. It is the probability of you saying that, hey customer, we are good, nothing to worry about. And in fact, you should be worrying. Are you guys with me? Are you guys with me? Are we on the same page? It is the probability, in quotes, of rejecting the null hypothesis when in fact we should not be rejecting the null hypothesis. Remember that initial conversation about assertiveness. Remember that initial conversation about being assertive. Do you guys understand? Do you guys understand the power of that? Do you guys understand how serious this conversation is? Do you guys understand how serious this conversation is? How many people in the planet would take this sample, calculate the sample, and say that it is all right? It is all right. Because this is less than 10.5. And what we are saying here is that, whoa, we do not have evidence to say that. We don't have evidence to say that. We should not be saying that. We should not be saying that. One sample t-test, p-distribution, William Gossett. One of the most important distributions in the body of knowledge of Lean Six Sigma. This is part of the umbrella of statistics, yes? This is by far one of the most important tests in the Lean Six Sigma body of knowledge. Why are we here? Why are we here? Because this kind of content will make you elite professionals. I want to make you, humbly speaking, elite professionals, different professionals, special professionals, elite. There are professionals and there are you. Yeah? Special professionals, special professionals. If you feel that you are tackling, addressing things that are making you special, type here for me, special. Type here for me, special. Questions about one sample T. Questions about one sample T. Professor, what assumptions must be met for us to use the t-distribution? When should we not use t-distribution or t-test? And Vindra, for this, because see, there are many areas, Vindra, that are extremely gray, and this is one of them. This is one of them. One of them. Because some people say that in order to use t-distribution, your data should be normal. And believe me, this is questionable. Questionable. I like the way Minitab presents. Minitab says your distribution should be symmetrical. Data should be independent. Sample must be randomly collected. And your distribution, the distribution based on the sample, should be symmetrical. If it is extremely skewed, then you may have problems. Then you may prefer a one sample sign, a non-parametric test. But if this is sufficiently or minimally symmetrical, you can just go ahead and use one sample T. Yeah, you can find that if you need some literature to back you up. I believe you can find this in Montgomery, but Minitab help is supported by many papers and books. Minitab help is I like to say that it is better than many statistics book, you know. So let me see. If you can easily find that. Yeah, so you may take a look here, Vindra. This is open, this is free for everyone. If you guys go on Google, Minitab 21, one sample T, take a look here, one sample T, data considerations, okay? Data considerations. So the population standard deviation is not known. If you know the population standard deviation, you should use one sample Z. Data must be continuous. Sample data should not be severely skewed. Interesting, right? So if your sample size is greater than 20 and the underlying distribution is unimodal or continuous, the hypothesis test performs appropriately even if the data is relatively skewed, yeah, moderately skewed, yeah. If your sample size is less than 20, you should graph the data to check for skewness and unusual observations. If the data is severely skewed or has many unusual observations, you use caution when interpret results. So see that it is gray. There is no like black and white, don't use skewed, not skewed. There is no like normality test here. Yeah, it's a kind of gray area. It's a kind of gray area. It's a kind of gray area. Yeah, but you should check if histogram shows that it is skewed, then my recommendation as your mentor would be to use one sample sign. That's the equivalent of one sample T for non-parametric. Yeah, this is like non-negotiable. Sample must be randomly selected. Yeah, otherwise you may not represent the population. And the observation should be independent from all other observations. Yeah, so one data point is not connected, you know, to another data point. There is no dependence among data points. Yes. There is the last topic is about sample size. I don't know if there is any black belt here. If there is any black belt student from myself here, let me know. Because there is the conversation about sample size, we need to touch power, the concept of power. Yeah, and this is then I will need like 3 or 4 hours with you guys. Yeah. Can I use T-distribution in analyzing production rates? Because, see, Lisa, it's continuous data. So I don't know how you are measuring that. if you have like parts per hour, you may use. Yeah, many people asking about when the population, see, even if it is not normal, but if it is extremely non-symmetrical, then you should use a non-parametric test named one sample sign, that instead of using mean, we use median. No, Trax, it's a gray area, you know? Yeah, how is the sound on a scale from 0 to 10? How is the sound? Maybe it's your volume. Maybe you need to increase the volume a little bit. Yeah? Questions? Guys, it's always a pleasure to be here with you all. Thank you so very much. I hope to see you again soon in these master classes. I am doing all my best to keep like as regular as possible these conversations on Tuesdays. Yes, on Tuesdays. So thank you so very much. I hope you've enjoyed this session and stay blessed.